Alrighty, welcome back everybody. Today we are still in that pre-security module. We're in network fundamentals and we're doing the intro to LAN module here. Um, so it has an estimate about 15 minutes. I'll try to keep this explanation to about 15 minutes as well. And it just says we're going to learn about some of the technologies and designs that power private networks. So we're not talking about huge, massive networks, stuff that you might find in, your house or little organizations, things like that. So nothing too crazy. We're going over the basics, and this does have one of those good videos in the front too. It's about 26 minutes, and it's some good stuff. So if you don't like my walkthrough of this, just get into it and watch it there. All right, TryHackMe does a very good job. So starting off with task one, there's introducing LAN topologies. So we're going to go over the different designs of networks. So if you've done your A plus or gotten a little bit into your network plus, you know about this. We will be doing this. We'll click on view site so that we can go over here and run the exercise. And that will kind of explain what's going on with these. Realistically, we're going over star, bus, and ring. If you're getting a job nowadays, it's primarily going to be star in some form or fashion. So let's go ahead and do this real quick. So ring topology, and in ring topology, all devices are connected to two others to create a full circle. So hey, look, it's a ring, and that's cool. Look, all this data going through. If he's trying to talk to this guy over here, it's going to flow to him and over there. So that's cool and great. But if any of the cables or if a device goes down, then no data will actually be passed. So that's what this is kind of explaining. Like, hey, we just cut this Ethernet cable right here, and now the ring is broken. So that kind of is a fairly big detriment. All right. Next, we'll go over a bus topology. So all the devices are connected to a single cable, and that cable is called the backbone. And data is sent in both left and right directions down the backbone until the packet's destination is reached. So that's cool. It's not as dependent on the cable like the last one. However, when we're talking about sheer bandwidth, if everyone's trying to talk to everybody and all these packets are going left, right, it can overload this backbone. So it will say right here, like in this next step, send as many packets as quickly as you can to try to take down the network. So if we're gonna say this is like 1, 2, 3, 4, 5, we're gonna have computer one talk all the way down the line to computer five, and I think that was this purple one. So we're going to spam this, and if you look, the backbone's going red, and we have taken down the network. So you're not really going to see those two in most jobs. I'm speaking now of pure experience here. My experience is I haven't seen that in enterprise work. Maybe maybe somebody does, but it's a lot easier to do things like star topology, which all the devices are connected with their own cable to this switch hub, whatever it may be, and that makes maintenance a lot easier too, because like if this breaks right here, then we just have to replace this one cable, and everything else is not being impacted. So in star topology, every packet is sent through the switch, which means if the switch goes down, the network will also go down for everybody. But at least typically, like in your networking closet, hopefully you have alerting and everything else saying, oh, something happened. So in this case, we take this little hammer and we bash the switch right there. And what do you know? We found all the topology flaws. We're going to go ahead and copy this flag right here. Boom. Let's go scroll down. You know, so we go over the topologies, then it's talking about what switch does. So switch is not a router. They are different. Hey, what do you know? Here's a router. So bam, let's go ahead and do that. Really quick, what is a switch? So switches are dedicated devices within a network that are designed to aggregate multiple other devices such as computers, printers, and any other networking capable device using Ethernet. Um, Typically, they have a whole bunch of ports. But if you're at home right now, and if you're, if you got the little cable modem thing from your ISP and you're like, wait a minute, is it just a router or is it a switch because it has all those ports in the back and you can plug in a couple different things in there? Those are kind of little all-in-ones. They are performing multiple different functions. It They are essentially a router, That also does this by definition what switches are doing. At an enterprise level, though, you will have those separated into dedicated devices. So if you're imagining, like, let's say this is an office building, and this switch one is on the east side of the office, and switch two is going for the west side of the office. So all these are on one side of the floor. This is on another side of the floor. Both switches would then connect to the router to then hit externally. All right. So routers are great because they connect other networks. Alrighty. I know in the previous one we said network can kind of be just conversations and everything. In this case, like private, and then we can go out to public. Um, I'm sure I did not explain that perfectly, but that's as far as we're getting. I am not a networking master. But what does LAN stand for? So these questions, you can read through them. All right. If you just want the answers, we're going to blow right through them. So that is a local area network. What is a verb given to the job that a router performs? Well, routers do routing. And what devices used to essentially connect multiple devices on the local network and transmit data to the correct location. The key thing there is it's a local network, so that's going to be the switch. Alrighty. And what topology is cost efficient to set up? Uh, it's three three layers right here, so we're going to go with the bus topology. And what topology is expensive to set up and maintain? That's going to be your star topology, because that has, as you're buying the switch in the middle. These other ones did not have a switch. Okay, so the switch is expensive, and then each device is getting its own cable RAN, whether it's to, a networking closet, however it may be terminated. Either way, all right. Like, it's just more expensive than other ones, but that's kind of what you see all the time. So it's good knowledge to know. It's not bad knowledge. Knowing more information is always great. Just in the normal workplace, I've never seen it, so I never seen bus or anything like that. So anyway, going on to a primer on subnetting. So as we previously discussed throughout the module so far, networks can be found in all shapes and sizes, ranging from small to large. Subnetting is a term given to splitting up a network into smaller miniature networks within itself. Think of it as slicing up a cake for your friends. There's only a certain amount of cake to go around, but everyone wants a piece. Subnetting is you decide who gets what slice and reserving a slice of this metaphorical cake. All right, so take a business, for example, you have different departments: accounting, finance, and HR. Alrighty, so we have the internet, we have a single router, we have one switch, and we have three different departments. So while you know where to send this information in real life to the correct department, networks need to know as well. So network admins use subnames to categorize and assign specific parts of a network to reflect this. So subname is achieved by splitting up the number of hosts so that can fit within the network, represented by a number called a subnet mask. Let's refer back to our diagram for the first room. So remember this IPv4 address with the 4 octets. Remember these numbers down here, the 0 through 255. I think we're going to be talking about that really soon in this little module, all right? So, hey, what do you know? Yep, it's made of 4 octets. The same goes for subnet mask, which is also represented as a number of 4 bytes, which is 32 bits, and it's ranging from 0 to 255. So subnets use IP addresses in 3 different ways. It identifies the network address, it identifies the host address, and the default gateway. So all those are fairly important. Let's see. So let's split up these 3 to better understand. So your network address identifies the start of the actual network and is used to identify the network's existence. Okay. So that is the network address. And here's an explanation. A device with IP address of 192.168.1.100 will be on the network identified by 192.168.1.0. Okay. Then our host address is an IP address. Here is used to identify a device on the subnet. Okay. So any device can have one of these addresses. So this is going to be, let's see, we're at 192.168.1.1. Cool. And then your default gateway is a special address assigned to the device on the network that is capable of sending information to another network. So that could be like your switch, okay? So any data that needs to go to the device that isn't on the same network, so if it's not on that 192.168.1.0 address, so that's the network address, will be sent to this device. These devices can use any host address, but usually they are either the first or the last host address in a network. So it's either .1 or it's .254. You notice it goes up to 255, but it's 254 as the last available address. All right, it's not wrong. It is right. Okay. So now in small networks such as your home, you will be on one subnet, and there is an unlikely chance that you need more than 254 devices connected at one time. If so, you have a giant house that's filled up with tons of devices. But for businesses and offices that have PCs, cameras, printers, sensors, subnetting takes place because when you do that, your subnets can provide good benefits like it's more efficient, security wise, it's easier to maintain, as well as full control. So you can subnet based on physical stuff, based on logical stuff, whatever the network admins ultimately can use to better manage the network. All right. Let's see. So we'll come on to explore exactly how subnetting provides these benefits at a later date. However, all for now, we need to understand is a security element to it. So let's take a typical cafe on the street. The cafe will have two networks, one for employees and one for the general public. So there's like a Starbucks, things like that. And subnetting allows you to separate these two use cases from each other while having the benefits of a connection to a larger network such as the internet. So what is the technical term for dividing up a network in smaller pieces? We've said it several times now. It is subnetting. And how many bits are in a subnet mask? Remember, we kind of read through it quick. All right, I'm not even gonna lie. Okay, if you don't already know this stuff, we are fire hosing basics of networking here. All right, so just understand the main foundation of what we're saying. As it hinted towards earlier, we're going to go into this more in depth later, but this is just the intro. We're still in pre security. So when you're thinking of subnet mask, all you need to know is there's 32 bits. If you can't recall that, don't worry. That's what Google's for, okay? Just know it's not some absurd amount, and that's why we get that range of. Oh, here we go. So what is the range of an octet? And that is at 0 through 255. You will not see a device with an IPv4 address that is like 192.168.1.500.300 as that last octet. It needs to be under 255. And most of them, the last one, .254 is typically reserved for a gateway or some other important device that the network administrators want to have as part of their schema. All right. I'm going to talk about DHCP later. Like, I'll hit on it there. Don't worry. So, what address is used to identify the start of the network? That's going to be your network address, okay? Boom. And what address is used to identify devices within a network? And that one, so all your devices can be considered as hosts. So it's going to be your, oh no, did I spell it wrong? Oh no, wait, address. I was speaking, it's host address, all right? And then what is the name used to identify the device responsible for sending data to another network? So remember, it is not, if we're talking about other networks, they can still be within, what am I going on about? All right. we're talking about the gateway here. All right. So the gateway, it is your default gateway gets a special address sign where it's sending from one network to another. So at home, that's going to be your little weird router combo thingamajigger. But we're going to put in default, if I can spell, that would be good. Gateway. All right. Moving on to task 3. All right. So ARP, which is the Address Resolution Protocol. So if we're going back a lesson, but we talked about MAC addresses and IP addresses as ways to identify devices on a network. Alrighty, so the Address Resolution Protocol allows a device to associate its MAC address to an IP address. So it's tying those guys together. So as you're conducting activities on network and traffic's being sent, you have like ARP tables that will be able to say, okay, your MAC address of blase blase ending in 50, you have an IP, the last octet where we assigned you out .20. All right, so as long as both of those are doing the same thing, and you know this host, this MAC address is not also doing passing traffic and everything as a different IP address, then your network, it's happy because it's saying, all right, we have what's called a cache, and our cache says this is supposed to be to that one and not anything crazy mix up. I kind of went off on a tangent there. All right, you are more than welcome to just read through this. It is good stuff. All right, but what's important to know, all right, the address resolution protocol is tying your MAC address to your IP address for the functions of identification. Alrighty, so it how it actually works though is pretty neat. So we're going to talk about the catch. The catch stores identifiers of other devices on the network. All right, so there's two types of messages. There's an ARP request as well as an ARP reply. Okay, so the ARP request is one device yelling out across the network. It's broadcasting what's the MAC of that address that owns this IP address. And so it's saying who's 192.168.1.50. Who's 50? Who's 50? And all the other devices are going to be quiet. They're not going to say anything because they're not 50. But if there is a device on your network that is .50, it will send that ARP reply back. And it will say, hey, I have the address of 50, that's me. And then in the cache, then, you know, they get to say, alrighty, your MAC address is tied to that IP. Cool. So a little bit talking back and forth just for identifying and tying devices with their physical identifier of their MAC address to a logical identifier of their IP address. All right. So what does ARP stand for? Address Resolution Protocol. All right. What category of ARP packets as a device? All right, let me go ahead and exit that split view a little bit bigger for you guys. All right, what category of ARP packets as a device, whether or not it has a specific address? So that is that broadcasting that we were talking about. So it's either going to be an ARP request or a reply, but because it's asking for it, we're going to say it's a request. Boom. Submit. My connection is not the most amazing here. So while that does that, all right, there we go, correct answer. All right, what address is used as a physical identifier for a device on network? So when we're thinking of identifiers, we're gonna have our MAC address and we're gonna have our IP address. All right, so the physical identifier, if you remember, it's what gets placed on, you know, that little piece of silicone inside of devices from the manufacturer. Boom. So MAC address and what address is used as a logical identifier. Even talking about them, they are IP addresses. All right, so IP address is that answer. Moving on to task 4, we got DHCP, which if you can understand DHCP, your life gets a lot easier, especially if you're troubleshooting things. If you don't understand DHCP, networking somehow seems like wizardry. So I would highly recommend, like this isn't even a long one either, but just absorbing what's going on here in this picture right here. So we're gonna read this real quick. So IP addresses can be assigned either manually, which is very tedious, and you do that by entering them physically into the device, or automatically, and most commonly by the DHCP server. So that's a dynamic host configuration protocol server. So again, dynamic host configuration protocol. If you think about that for a second, what is a dynamic host? So if we go back, I believe it is in here. So in this area, we're talking about host addresses. So any device, already, any device on the network. Dynamic, it's the just opposite of static here, where it can change because DHCP is essentially leasing out IP addresses. In configuration protocol, it's it's part of your configuration. All right, it's setting this up for your device whenever it connects to the network. So if it doesn't already have an IP address that was statically assigned to it, or if it, lease it out earlier, whatnot. But anyway, it's we're just gonna run through this so I don't ramble on. I do it a lot. Sorry, guys. Alrighty. So when a device connects on the network, if it has not already been manually assigned an IP address, it sends out a DHCP discover request. All right. And that's to see if there's any DHCP servers on the network. So you plug in your laptop onto a network, and there's a port right there. You plug it in, and if it does not have a IP address, because you don't know what the schema of that IP address is, so you can't really statically assign it because you don't know what their actual subnets and everything look like. So you plug in, and they have a DHCP server. As soon as your device plugs in and it's looking for that network connection, it's doing its thinking thing on the little network icon. DHCP discover request goes out. The DHCP server says, "Oh, I see you. Here's an available IP address," because it has its own rules and everything of how it's managing all these available addresses, and it does that through an offer. So that is the DHCP offer. So the device then needs to confirm that, and it does that through a DHCP request. Now, stop for a second. If you're like me, I was like, when I was learning this, I'm like, why would it not then, like, it isn't requesting an address at the beginning? Like, it just seems kind of awkward to do a discovery offer then a request just in that vocab, but the discover needs to happen first before anything else. Just see if anything's even out there. The DHCP server sees them, it offers it. The DHCP request is from that host talking back to the DHCP server to kind of confirm what's going on here, saying, "Yep, I do want to use that IP address that you are offering me." Okay, and then the DHCP server acknowledges that request through an act, so an accent, so it acknowledges it. So in this right here, like, I know I'm drilling down on DHCP. All the topics that we talked about are very, very important. This ties together just how devices even start to operate on a network, which is fun. So we have the discover. It's looking for the DHCP server, your devices. The DHCP server sees them, offers them an IP address. This is 192.168.1.10. All right. Then your device, your host says, "Yep, that'll be great. I'll start using .10. Alrighty, you offered it. I'm gonna start using it." And then the DHCP server says, "Sweet. Here's your lease time of it." So in this example, it says you can have that for 24 hours. It typically you don't want to assign it out indefinitely because your subnet only has so many available IP addresses. So for like Starbucks, airport, guest, things like that, when people sign, you don't give them a very long lease because you don't want them to stay there all the time, right? Starbucks wants foot traffic. I don't know if you've ever been in a Starbucks and if you try to work there all day, but I'm pretty sure at some point it times out and then you have to redo it, and you might not get that same address because the DHCP server is seeing it as a new request. All right. But let's go ahead and finish this out really quick. So what type of DHCP packet is used by a device to retrieve? So to retrieve an IP address. Think about it. DHCP discover. All right. So what type of DHCP packet does a device send once it has been offered an IP address? So we've done discovery. Alrighty. From discovery, it gets offered it. The next one is going to be your request. So DHCP request. And oh no, DH oh, DHCP request. There we go. And finally, what is the last DHCP packet that is sent to a device from a DHCP server? and that's that acknowledgement packet. But we're not going to spell out acknowledge. We're going to do DHCP ACK. Boom, hooray, we got it. All right. So congratulations. Thanks for watching, everybody. We made it through the intro to LAN room. The next one is going to be about the OSI model, which we are going through the foundations of networking. All right. But thanks for watching, and see you guys at the next one.